Good. So the Coriolis effect is an apparent curve of the path of different objects as they move within something that's rotating. For us, we're going to focus on the Coriolis effect in wind. Now, we all know that air always moves from higher pressure to lower pressure. So in this diagram here, we've got a high pressure system and a low pressure system. We would assume that the air would want to go from the high pressure system towards the low pressure system, and it does. But since the Earth is rotating, the actual motion causes that wind to curve to the right, at least in the northern hemisphere. In the southern hemisphere, it'll curve to the left. So the wind will do that. The wind will curve to the right as it's moving along instead of just going straight from high to low. The reason this happens is because the Earth is rotating. It's known as the Coriolis effect. So if we look at, here's a nice definition for your notes. The wind appears to curve due to the Earth's rotation. That's why this curve happens. It's all because the Earth is spinning, all because the Earth rotates. If the Earth was staying still, if the Earth wasn't spinning, then the wind would move straight, the air would move straight from high pressure to low pressure. We wouldn't have this apparent curve that we see. If we take a look at a globe, here's the Earth. If we put a high pressure here, and let's put a low pressure here. So there's our high pressure and low pressure. We would assume that the air would move from high to low, and it does. The air is going to try and move from high to low, but it's going to curve to the right. Now you might look at that and say, oh wait, he just made a mistake. He said curves to the right, but that arrow is going to the left. Yes, but you've got to be the wind. So what we're going to do is we're going to rotate this, and we put it in an orientation so we could see that the air is moving from the high to the low, that it does curve to the right. You've got to put yourself in a position so that you're facing the same direction that the wind is moving. The air is going to move from the high to the low. It's going to curve to the right. In the southern hemisphere, that curve is to the left. So if there's a high pressure system here, a low pressure system over here, in the southern hemisphere, the air wants to move from high to low, but in the southern hemisphere, that curve is to the left. So we see that in the northern hemisphere, the curve is to the right. In the southern hemisphere, the curve is always to the left. And it's important that you face the same direction that the wind is facing. So we see a curve to the right in the northern hemisphere, and the southern hemisphere, that curve is always going to be to the left. And that's going to affect the way storms circulate, the way they rotate. Because of this, because these winds are curving to the right and curving to the left, it sets up certain wind belts or patterns of wind on the Earth. So if I take a look at the Earth here, there's 0 degrees, which represents the equator, and I've got a few others on there as well. The wind is going to move towards the equator. The equator tends to be a lower pressure area. So as the wind is moving towards the equator, it's going to curve to the right. So between 30 degrees north and the equator, the wind tends to move like this. In the southern hemisphere, it's the same thing, but remember, now instead of curving to the right, we're curving to the left. Remember, a lot of you might look at the curves up here at 0 to 30 and say, wait a second, that's curving to the right, isn't it? But remember, we're going to look at this thing from the direction of the wind. So if I'm looking at this in the direction of the wind, this is curving to the right. I've got to be there for the direction of the wind. All right, so we've got this planetary wind belt that's starting to be set up here. This also happens at the other levels as well. But in this 30-degree north tends to be, and 30-degree south tends to be a higher pressure, so the wind's going to move away from that, curving to the right, curving to the right. Same thing down in the southern hemisphere. And again, up there. So our Earth has some planetary wind belts. You can see this when we get to page 14 of your reference tables. We see these wind belts set up. The reason we have these wind belts is because of the Coriolis effect. Like we said, generally speaking, the equator tends to have a lower pressure. 30 degrees north tends to have a higher pressure. The wind is not going to go straight from high to low, but is going to curve to the right, which means between 0 degrees, the equator, and 30 degrees north, generally the wind pattern is from the northeast to the southwest. Where we live up here at 43 degrees, we're in this zone here, and winds generally move from the southwest towards the northeast. And we'll investigate that with a little bit more detail in the future. So here's page 14 of your reference tables, and we can see that these curving winds are caused by the Coriolis effect. This happens on other planets too. Here's a nice picture of Jupiter, and we can see that Jupiter shows these beautiful bands. Jupiter spins rapidly, and because of that, it sets up these bands of wind. Here's the Earth is spinning. That causes the Coriolis effect, which is where winds appear to curve due to the Earth's rotation. The diagram here shows the northern hemisphere. Air moves from high to low. In the northern hemisphere, the wind curves to the right.